here to talk to you about engineering in a zero-carbon future is the Sustainability Director at Siemens, Rabe.
Thank you very
Welcome.
much, David. Thanks.
Go get him.
Thank you. And dear David, also dear Kate, thanks for these kind words. They are too nice, I have to say. What is not too nice of you is that you came up with the idea to create such a tremendously cool event and to invite this crowd of the brightest people from around the world to come together here. So you're all here for a reason. Another thanks, first of all, needs to go to the city of Bangkok. So dear Lord Mayor, thanks for having us here. And also a big hand to all the supporters backstage, the policemen on the street, the caterers, all the volunteers. Please give them a big hand. So, I'm very excited that I'm able to talk to you about climate change, a topic that perfectly suits to this very international setting. So out of all the Sustainable Development Goals, number 13 is maybe the most international of all because it affects us all. Or as Kofi Annan put it yesterday, or the day before yesterday, we swim or sink in this together. And I'm also very happy to be able to talk to you about climate change at a time when there's no discussion anymore whether this is an important topic or whether there is even a man-made climate change. It was in 2015, so this very year, that the G7 heads of state concluded that we will have to decarbonize the global economy by the end of the decade, ideally much earlier than the end of the decade. And as you can see, we have also two balloons here representing the carbonized world and the decarbonized world, and that is basically the way we have to go over the remaining of the century and hopefully a very fast pace towards the decarbonized world. And there has been no week without momentum. I don't know if any of my slides can be found here. Is it this one? Okay, then the voting, we will be doing some voting later, but in the old way. So let's see. Yeah, no week without momentum, and governments, NGOs, private companies have given a lot of commitment and shown action recently. And I think if you just read through these things, no more before in history have we seen such a speed in the way we do on decarbonization and work on climate change. So the first thing on the list of takeaways that I want you to keep is that in 2015, this very year, this is the point of no return. It's clear there will be a decarbonization, and this year is the turning point. And I'm also confident that initiatives like the Call on COP, where I'm also honored to be video recorded a little later, will help to ensure that the negotiators in Paris know what to do. So this is the title of my little impulse here, Engineering into a Zero Carbon Future. And let me rearrange that a bit for you. I will start with some maybe simplified one-on-ones, basic principles on climate change or decarbonization. And I will show that actually decarbonization comes with a positive business case. In part 2, I will explain why I'm very confident that our engineers will find all the required solutions for those very few where we haven't found them anyhow yet. And I will summarize with a positive view into the future, as we have to decarbonize for the sake of your next generation, as we can decarbonize, and as we better want to decarbonize because it has a positive business case. And as one young world, is all about action. I will also come later back to you with what I need you to do. Let me start with the idea of the carbon budget. So who knows what the carbon budget is? Yeah, raise your hand if you do. Okay, there's some first row. Okay, everywhere. Good. And hopefully everybody from Siemens, by the way, has raised their hands because we talked about that just 2 days ago. I will watch on video and check upon. So since the Industrial Revolution, we have emitted 2,000 gigaton of CO2. That's cumulated. And today we are emitting between 40 and 50 gigaton a year. I didn't put all the numbers because I don't want you to remember all the numbers, but more the principles behind. So without a further decoupling of GDP development and growth from energy usage and CO2 emission, we would be on this red track. That would lead us to a 5 centigrade warmer planet towards the end of this century. And of course, I don't have to tell you, this would have tremendous impact. Bangkok would be flooded, like many other places close to the shores. Before we go to Paris, to the climate conference in 2 weeks, we have collected pledges from all countries. And the sum of those pledges, according to the scientists, would lead us to roughly this yellow line here. Unfortunately, this is still roughly a degree too much. And 1 degree can make a big difference. So if we still want to stick to the target of remaining below 2 centigrade warming, and actually to stay significantly below 2 degrees if possible, we only have, and that is the carbon budget, we only have 1 gigaton left to be emitted during this century. Now, either from tomorrow on, we will cut back dramatically. Then this would correspond to roughly 1,000 gigatons, or 1 trillion tons. Or, if we just continue like we do today, our budget would be eaten up in only 25 years from now. I think both scenarios are maybe not realistic, so what we need to do is, we can play around a bit between these two. We need to land it at something that looks like that green line, so that we can stay below 2 centigrade global warming, and ideally a lot below 2 centigrades. Now, what is my personal view on Paris? I think the countries will agree on something hopefully a little lower than the yellow line, and then a review mechanism that will allow to get us on the green line as soon as possible, or maybe even a little below this green line. In any case, reaching that green line or not emitting more than 1,000 gigatons until the end of the century, that would mean to leave 3/4 of all known fossil fuels in the ground. So we cannot extract them and we cannot burn them, otherwise we will not, we will overspend on our budget. So now, what does it mean for us personally, individually? Today, every person on Earth emits roughly 5 gigaton on average. Of course, this differs big time between the countries, etc. But on average, it's 5 tons. But for the remaining 85 years, per capita, and if you want to stick to our budget, it can only be 1.5 gigatons. So how much is 1.5 gigatons, and how much do you emit? Now I want those to stand up here who own a car. Come on, please. Everybody who owns a car, please stand up. And it's all right. I also have a car. There's nothing wrong about it. So I will not blame you on that. So okay, so we have still quite a majority of people who have a car. Now, actually, how much CO2 do you emit when you drive a car? Of course, this depends a lot on the mileage, on the distances you drive, but let's assume a typical 15,000 kilometers a year or 10,000 miles a year. So what do you think? So those who have a car, who believe it's 0.5 ton a year, please sit down. And those who believe it's 2 ton, please remain standing. We will come to electric car, don't worry. Well, those who remain standing are right. And maybe this is also a good opportunity. You can sit down again. This is also a good opportunity to introduce the concept of carbon pricing. And the concept to put a price on an undesirable externality is nothing new to us. And the advantage of doing that is actually to allow then the economic system to take care of a problem. And this is what we want. So now if you ask me what is the right price per ton, I would have to say, I don't know. If I ask people, I get answers between 10 euro a ton up to 200 euro a ton. So I always like to take 50 euro a ton, somewhere in between, and just to have something to calculate with. It doesn't matter the exact number, but just to give you some fingertip feeling. And yeah, 50 euro per ton for your car would actually increase the cost of you driving by 100 euros a year. That's not prohibitive, and I would assume most of you would still continue using your car. But as Kate said, that problem will go away because you will be shifting to electric cars sooner or later anyhow. So let's look at another example. Who of you had this view just recently? Raise your hands. Yeah, and I mean, we did this voting, I think, on the first day, and most of you arrived by plane, so I hope you had a nice window seat, then you must have had this view. So now let's do the same exercise here. And what do you think? On the flight, let's say from Europe here to Bangkok and return, how much CO2 do we emit? So those who believe it is less than the car was 2 tons, who believe it was 1 ton, please raise your hand. Per passenger. Yeah, per plane, this would be... No, but it's a good question. It's per passenger. So, okay. So who believes that this is 2 tons, so equivalent to driving a car for a whole year? Okay. And who believes it's even more than the cars, 3.5 tons? Then you guys are actually right. And now you have understood my trick. It's always the last. And here, if the airline would have to charge you for that, they would have to charge you 175 euro for that flight ticket, including return. By the way, I supported an offsetting measure for my flights here, and I can only encourage everyone to do the same for the air travel that you cannot avoid. Let me come to the last example here. So what do we have here? We have cooling towers, we have chimneys, conveyor belts for coal. It's a coal power plant. So let's say we would apply the same 50 euro per ton on a coal power plant. What would that do? I mean, like we learned from the car, from the plane, yes, it makes it more expensive, but it doesn't completely destroy the business case. Here it's different. So just applying 50 euro a ton would double the cost for every unit of electricity out of a coal power plant. And this is why, and this is the business case behind why the British government has just yesterday announced that they will turn off all coal power plants in the country latest by 2025. This hasn't been aired a lot in the press, I have to say, while I believe this is a very significant statement. So please give a big hand. Yes, Kate, thanks. This is really cool. And this is something we need to talk about, and we need to encourage also other countries to follow suit. Talking about business case, decarbonization has a clearly positive business case, and there are 2 ways to look at it. As an optimist, I would like to start looking at it from the positive side, of course. First example, as part of our own decarbonization program at Siemens, we are currently investing 100 million in our own plants and facilities to increase energy efficiency and thereby also reduce carbon dioxide. And the payback period of that is less than 5 years, which translates into 20% return, roughly. And this is something every CFO, every controller, they love it. So they even say, yeah, why haven't we done it earlier? I said, yeah. And here you can see a nice picture, hopefully. Oh, only one nice picture. This is London Array. This is the world's largest wind farm. It's roughly 100 kilometers away from central London. This also was a very positive business case for everyone involved. For the project developer, they earned a lot of money. For all the suppliers, including us, they were happy. The owner is happy because it offers them a constant revenue stream over the many, many years to come. And also society is very happy because the electricity that is produced out of that has the lowest, what we call, societal cost of electricity, which not only includes carbon dioxide and externalities, but also the amount of work created in the country. This is far more labor intensive than burning fossil fuels. If you're interested, you can Google that up. Society's cost of electricity is a concept we developed to try to calculate all of that. And if you're not convinced yet, well, let's look at the negative side to calculate that. If it works. So here, the damage caused by 2 recent hurricanes in the United States has been estimated to be 200 billion US dollar, even in excess to 200 billion US dollar. For that amount of money, you could have bought London Array 100 times. And in 10 to 15 years, with the cost out we are doing at the moment on our wind turbines, you will be able to buy London Array 200 times. And for 300 times, or with 300 London Arrays, you can power the electricity demand of Germany, my home country. It's number 4 economy, number 6 emitter in the world. 300 of those parks will power the whole country for the next 30 plus years, because that's a lifespan of those machines. And if you continue that math, you will arrive that only one of those natural disasters would equivalent to the cost of powering a whole country like Germany. So it's a very clear business case. So now, fancy formula, and you have no clue what this means by now. I hope that you will in only 1 minute. And then hopefully this formula helps you to memorize my point. Today, we have roughly 21% of all our power, electric power, generated renewable in the grid. So that means there's still 79% to go. I'm not worried about that, because renewable energy has become so cheap that we will manage anyhow. What I'm more worried about is that there are more emitters. So industrial processes, mobility, et cetera, this is also what needs to be electrified first so that we can decarbonize. There's forest and agriculture and forestry, I know. There are also ways to look after that, not through electrification, but this can all be done by electrification. Then we will save a bit through efficiency increase, which is good, that's our friend. On the other side, there's also a demand increase. So we will be having more people on the globe, and their expectation of life will also increase, which is a good thing in principle. And just think about it, the time we spend here discussing this topic, half an hour, 5,000 people will be more on this planet. So that's 3 times this auditorium just in the span while I'm talking. And so better that efficiency beats the demand increase, because otherwise it's more than 300% that we have to go. Yeah, electrification, automation, digitalization, these are the levers, and here we have growth and prosperity, hopefully. So now engineering, and I want to show you a couple of examples why I believe that our engineers are well on track, and there won't be any showstopper or bottleneck in terms of technology. And with digitalization, we heard about that before, we're just getting a further lever and tool that our engineers, all the generations before, couldn't rely on. And only extrapolating what we have done in the past makes me feel very confident. And I'm showing a couple of examples here. First example, and you see I love wind turbines. I was in the wind industry a while, but it's also really easy to understand looking at a wind turbine. So this is 1982 wind turbine. I was in second grade elementary school there. It's in Denmark, in Jutland. The turbine still works like a Swiss clockwork. Every blade is 5 meters in length. It's about the size of a minivan. And by the way, we even took a minivan to get it to the site. Ever since, we could reduce cost of electricity by 40% per decade. 40%. That's the Moore's law of wind power, so to say. It's not double every 18 months, but minus 40% in cost every decade. And this is where we are now. So this machine it's real. I mean, I have no picture, but I would have had pictures, but it's not on the drawing board. It's out at our customer site, and here it's almost 300 times stronger. It is only 5% of the specific weight of the old machine. That shows basically what we have done, and the blade is 75 meters long. And no, we don't use any minivans any longer. So again, extrapolating just that, what happened during one generation makes me feel very confident that technology will not be the showstopper. We said we need to electrify industrial processes. So who can help me with this formula? So somebody with a chemistry degree here, there must be some. Please raise your hand. Who has a chemistry? Yeah, you do. Then please excuse my very simplistic version of this of the steam reduction process. Yes. So what it does is we take methane, steam, and then we get hydrogen, what we want. But for every atom of hydrogen, we also get one molecule. We get a molecule of CO2, which we don't want. So this is the future. I don't know the direction where to click at. So this is the future. So it's an electric hydrolyzer where we use cheap renewable energy and water, and we in principle only get hydrogen, what we want, and oxygen. And this is real. This exists. It's not yet widely used, but it will pretty soon displace the old way of doing things. Electrification of transportation, that has already started. And here's a picture from Bangkok's mass transportation system. Already exists. It takes people off the road and onto the train. It's faster and cleaner than the alternatives. Cars. As a good German, I had to pick a German car. But you know more about electric cars than I do, so batteries are getting cheaper, range is getting extended, so no worries. And it will displace conventional cars. Apart from the battery, there's another technology frontier that is fast charging. That is the other side of the solution. One example, this is from Hamburg, Germany, where we have in operation a line of all-electric city buses that are in regular use. So it's not a concept; it's in use. They have a battery the size of a BMW i3 electric passenger car. So it's relatively small for a bus. The passenger can go 200 kilometers. The bus can only do 30 or so, but it doesn't matter because 30 is good enough to run all the stops on the city line. And it only takes 5 minutes for us to recharge that battery, which makes it very hard for the poor bus driver to fetch a coffee because he only has 5 minutes before he can go off again. So 3/4 of the emissions from transportation are land transportation, and as you can see, we can electrify it with no problem. So let's look at sea and air. The first thing at sea to do is to actually give electricity to ships while they are at anchor or in the port, which sounds quite obvious, but it's not real in most of the cases. So that saves from inefficient engine idling in harbors, and that's a no-brainer, and it's happening. The next step is what you see here. This is a true full electric ship. It's in Norway. It's running. It's shuttling along the fjord, and it's being charged on every stop. It works. I don't have the answer yet here for you how we will do that for the large container ships. But eventually, if you think about that, container ships are only around since 50 years, we will find a way, I'm not worried. And they are, of course, ideas. So now taking it to the air, or not quite yet, because that plane is still not in the air. And what you can see here is a taxi bot. It's an all-electric vehicle that propels the plane while aground. The jet engines can be switched off immediately after landing and only needs to be turned off directly before departure. For a big Airbus 380, that saves 1 ton of kerosene for every movement on the ground. 1 ton. And the payback times is less than a year, also because it tremendously extends on the service intervals of the planes, because the jet engines are not running in non-efficient states. And it exists. Frankfurt Airport is currently introduced. Still not in the air. This is the strongest electric engine, at least in terms of specific power. This has 5 kilowatt per kilogram. To give you a benchmark, a typical electric engine has less than 1 kilowatt per kilogram, and even the strongest e-cars in a Tesla, for example, they have roughly 2 kilowatt per kilogram. So this is a really strong engine. And this engine is flying. So we have electric planes. Of course, this is only a few-seater. Of course, this can only be used on short trips. I know that. And again, here I don't have the answer for you how exactly we will electrify the long haul, but also there are ideas. Maybe it's through indirect electrification via hydrogen, but also we have to remember 85 years to get to here, end of the century still, and I think the first transatlantic passenger flight was 77 years ago. So we will figure that out. Now, into the future. Who has seen that video, or that movie, I have to say? Okay. It's hard to see with the lights, but yeah, there's some hands up. Yeah, Al Gore, An Inconvenient Truth, 8 years ago. I just rewatched it recently, and those who haven't should, because the mechanics and the predictions of 2010 turned out to be right, and we have to give a lot of credit to that. I believe that today, another title could rather be a truth. We leave out the inconvenient, because if it's right what I've just said, if we have to do it anyhow for the generation to follow yours, as I tried to show, the technology is there, and as it is even a positive business case, so we should be doing it for selfish reasons, then why in the hell are we not doing it? So, here we are, 2015. What is missing and what can we do? So now I want everybody who wants to do something about climate change to stand up now. So those who want to do something, stand up. Oh, thanks, yeah. Wow, that's impressive. And, I don't want you to like my presentation. I also don't want you to share my presentation. I want you to do your own presentation. I want you to talk to your family, to your friends, to your peers, to your colleagues, to your bosses, to your employees, and I want you to lead by example. And as you can see, the clock is ticking. So I want you now to think about to whom to talk first and what to do differently from Monday on, next Monday onwards when you're back at home. So, now we have reached the end of the century. We are hopefully already a while at the decarbonized world. And you know, we have to be at the decarbonized world rather in the first half of the century than later. So first of all, thank you very much to listen to my words, and looking forward to your questions.